Hello everyone, and in today's videos we're going to be talking about correlation, AS correlation. So here's a question for us to have a look at. So it says a company is introducing a job evaluation scheme. Points will be awarded to each job based on the qualifications and the skills needed and the level of responsibility. Pay, £Y, will then be allocated to each job according to the number of points awarded. Before the scheme is introduced, a random sample of 8 employees was taken, and the linear regression equation of pay on points was y is equal to 4.5x minus 47. Describe the correlation between pay and points. Okay. Now, you can imagine we've got the mark scheme here for reference, which is going to be helpful to us. But you can imagine this correlation line, if we were to sketch it, it's going to have a positive gradient, okay, of 4.5 and an intercept here of, an intercept of minus 47. So actually, it's going to be down here. So it's going to look something like this, okay? So minus 47 there, and it has a gradient of 4.5. So because it's got a positive gradient, we're going to say it has a positive correlation. Okay, so part A, we would just say a positive correlation. Now, part B, it says give an interpretation of the gradient of this regression line. Okay, so the context is it's basically how much pay you get versus the points that you have. Okay, and what this means is that for every extra point that you get awarded, so we have here maybe say the points, and here we have the pay. For every extra point you get awarded, you get paid an extra £4.50. Okay, so there's an extra, and you can see they've said that here in the mark scheme. Every extra point gives an extra £4.50. Okay, so that's the significance of the gradient. I've seen them ask that quite a few times, so look out for that. And then part C, explain why this model might not be appropriate for all jobs in the company. Okay, well, the reason why is you can see here, there is a certain point at which, if you're below a certain point on the pay scale, in fact, that point is 11, okay? If you've got less than 11 points, this model predicts that you're going to get negative pay. In other words, you're going to have to be paying to work at the company, which clearly makes no sense at all, okay? So what we're saying here is that if you've got less than 11 points, it's going to give you a pay that is less than 0, which means that you would be paying to work at the company, which is ridiculous. Okay, so there we go. That is that question. Okay, perfect. Right, that's that first question. Now let's have a because that didn't take long. Let's just have a look at another question that's on correlation like this, and also has a little bit of sampling in it. So here's another question, and this question is also to do with correlation and sampling. So let's have a look at this second question. Now, in this second question, what have we got? It says, in a sixth form college has 84 students, okay? And in year 12 and 56 students in year 13. The head teacher selects a stratified sample of 40 students, stratified by year group. Describe how this sample could be taken. 3 marks. Okay. Well, if we're going to do this, the first step is we need to create a sampling frame. Okay. And what we need to do to create a sampling frame is we need to give each year 12 student a number from 1 to 84, because there are 84 year 12 students. And we need to give each year 13 student a number from 1 to 56. Okay, so we're creating our sampling frame. The second step is we need to then calculate the sample size. Okay, so how many students are we going to ask from year 12, and how many students are we going to ask from year 13? And the way we do that is we're going to have the 84 year 12 students divided by the total number of students times 40, because we want a sample of size 40. And that's 3/5 times 40, which is 24 students from year 12. We could just say then that we just need to do 40 take away 24 from year 13, but let's calculate it just to make sure that we're showing our working. So there are 56 students in year 13 out of a total of 84 add 56. We times that by 40, so that simplifies to 2/5 times by 40, so 16 students from year 13. So we need to be asking 24 year 12s and we need to be asking 16 year 13s. Okay. Then the final step is we now need to choose the students. So we now need to use a random number generator to select 24 students from year 12, okay, from the numbers 1 to 84. And then a random number generator to select 16 students from 1 to 56 out of year 13, okay? And that's going to give us our 3 marks, okay? Because we've got basically everything that we need to do there. We've basically said we've created a sampling frame, we have calculated how many we need, and we've mentioned the fact that we then need to randomly select the students. Perfect. Now, the head teacher is investigating the relationship between the amount of sleep, S hours, that each student had the night before they took an aptitude test and their performance in the test. So this is now the correlation part of this question. So for a sample of 40 students, he finds that the equation of the regression line of P on S to be P is equal to 26.1 plus 5.60 S. With reference to this equation, describe the effect that an extra half an hour sleep may have on average on a student's performance in the aptitude test. Okay, so basically we've got a picture here where we have a regression line, okay, of P on S, and we're basically seeing that for every extra hour that they sleep, this model predicts they're going to get an extra 5.60 marks in the exam, okay? Because the 5.6 is like the gradient, okay? If we were to draw a little sketch of this, we would have a graph like this. We'd have a gradient of 5.6 and it would intercept here at 26.1 and a gradient of 5.6. So that means that if they sleep for an extra half an hour, they're going to gain an extra additional 2.0 marks on the test. So that's our answer to part B. Now, part C, okay, what's going on here with part C? So it says, describe a limitation of this model, okay? So basically, there's no upper limit to this model. So this model predicts that the longer you sleep, the higher you're going to perform on the test. And in fact, the most highest performing students are the students who never wake up to even take the test in the first place, which is clearly ridiculous. So the limitation of this model is it predicts that the longer you sleep, the better you score, and the students who never wake up at all are going to get the highest score, which is clearly absurd. Okay, so that's a couple of questions there on correlation and one on sampling. I hope that you found that helpful, and I will see you in the next video.